Hello. So this is the first video of a three-video series of using Jupyter Notebook, or previously known as the iPython Notebook, to process and clean and infer information. I'm going to use Jupyter Notebook uh, as and the SWITRS data as collision data as example. Let's get started. So the first step, I'm going to launch the iPython Notebook or Jupyter Notebook. It doesn't really matter here. You can put either Jupyter or iPython Notebook. And I'm going to point it to the U drive for my drive where I saved my code and information and the data, original data. But uh, you can put point it to your corresponding drive, for example, N drive, uh, to process the information. And then I'm gonna go to the product folder, and then my information is saved as in the data SWITRS folder. Um, but let me launch a Python 3 notebook. I'm gonna call it data processing, data exploration, and processing. First, I'm gonna import the OS module, OS library in the Python, uh, because I'm gonna deal with the operation system out of the Python a little bit. And then also I'm gonna use the NumPy notebook, pandas, and then I'm gonna set the panda options to display pretty much as many columns as possible and rows as well, of course, so that later I can show as clear as possible. And then now, because I saved my information in this drive, you can put the directory here for your raw data directory so that you can immediately um, read all the information from that directory as CSV file. It's okay to using Excel file as well, as long as it has a clean format. So I'm gonna use import the sh, which it represents all the data records that have a severe impact, and then truck information. This is all the truck collision relevant data. And then let's explore. So let me just only show the first five records. So we can see the most important information that we're curious in this in the product I was working on was the state route ID, but it seems like a lot of them are 0. So let's see how much. So I'm particularly interested in the state route ID. So you can see there's a lot of zeros, and we can use the value counts method to see how many zeros that we have. So you can see there's about 7,000. And then let's see how many percentage. So you can see about 1/3 of the information in the data frame sh are 0 or missing information. I'm not saying the state route information are correct, but there's a lot of missing zeros as well. Let's see truck. Information. Oops. Value counts method. I can see there's about 17,000 records. And then let's see the percentage truck. So there's more than half. Okay. So that's where we need to use other information. For example, the coordinates, x and y, and then also the coordinates reported by the Havik petrol. Um, or you can use the information manually input by the police officers or highway patrol officers in terms of the primary, secondary. Let's explore this piece of information a little bit. Primary road count values. You see the count values is not right, it's value count. Okay, and you can see the data is not very consistent. Sometimes it's just route 5, and sometimes it's called I-5 northbound, sometimes I-5. Let me just sort the index a little bit and see it clear. And you can see sometimes it's even called, the police officer probably wrote it wrong, sometimes even calling explanation 5, so which is actually the I-5. And later, because we can infer from the coordinates, but there's a lot of them that have inconsistent format for saying, referring to the same thing. So what we're interested is to know, infer the information. For example, the 21st Street, how can we infer it's as a street rather than a state route? And some of them are state routes 43 or SR 43 or SR space 43 or state route 43. We need to differentiate all of them in order to get the correct information. So let's first we need to let's explore the column arrangement for SH as well as the truck columns. So you can see they are exactly the same. So there's a potential that we can just simply concatenate, even though we need to examine, of course, the case ID. We need to make sure because some of them are overlapping with each other, but we can eliminate the redundant information a little bit later. Let's first define a function by inputting the data frame as well as the data source, and then I'm gonna just first examine, make sure the state highway. You see the column name, which is state. See, state highway. Okay, we need to make sure the state highway are all pointing to Y to make sure, because we're only interested in state highway information. What we're also interested, because we can infer the location of the collision by using the coordinates, so we're only interested in those coordinates that does not that's equals 0. Okay, df equals 0 and or df the last column x chp equals 0. And then I'm gonna make sure I'm gonna flag, create a new column to say where this information comes from, which data frame it is come from. I'm gonna return it, and then here's the definition. Oh, I need to. Okay, so now I'm gonna create a list to encompass the two process data framework, and then I'm gonna loop over the data frame, the two data frame. Let's see. First, I'm gonna put the two data frame in a list, and then also I'm interested in is the name of the list. And then I'm not gonna call the data, the function, and then I'm gonna append this into the list. Let's see what we have. So I have a list of two things. First, we have the information from the SH, and then secondly, we have the information from the truck. Now, let's create a new data frame to